let me use a few graphs to give you a quick introduction to limit. This is probably the easiest and the fastest way to put the concept into your mind. So what is limit? When you are thinking about limit, limit is all about approach. So the keyword is approach. As x approaches to a number, y approaches to what value? And the correct way to write a limit is right in the middle. So we have limit of f of x, x approaches to a. So the limit as x approaches to a of f of x. So we have a function f of x. As x approaches to a number, y approaches to what number? So let's take a look at the first picture. The first picture, I have a graph. I have a few points on the graph. So the first limit that I am asking is limit of f of x as x approaches to a. So let's find out where x approaches to a. So x approaches to a is right over here, right? So what is x approaches to a mean? So x approaches to a, just follow the curve along. So you are right here, so you are approaching a. So at this point, what is y equals to? Y is equals to b, right? So as x approaches to a from the left, or as x approaches to a from the right hand side, y approaches to b. So that means the answer is y, the limit is equals to b. So let me match the color for you. So this is equals to b. What about x approaches to c? So c is right over here. So as x approaches to c from the left, as x approaches to c from the right, y approaches to d. So the answer is equals to d. But you might asking, hey, so when you plug in x equals to c, so when x equals to c, and then you plug it into the function f of c, that is not equal to d, right? Why is that not equal to d? Because there is an open circle. What is open circle mean? Open circle means for f of x at that curve, for f of x, when x is equals to c, y is not equals to d. So that's why you have an open circle right there. But how about this point? This point is just for a function evaluation. That is f of c equals to what? So what is f of c? F of c is equals to e. So there is one individual point when x is equals to c, y is equal to e. So that's the first graph. And then let me say this one more time. As x approaches to c from the left and from the right, y approaches to d. But if you're thinking about this, f of c is not equals to d. Yes, correct. That is totally correct. F of c is not equals to d if you are going to do a function evaluation. When x is equals to c, y is not equals to d. But when you are talking about limit, because what's the keyword? The keyword is approach. When you are using the concept approach, the limit exists. But if you go straight to a function evaluation, that doesn't exist. But for limit, that exists. All right, so let's take a look at the next graph. So the next graph is we have a yellow curve, so g of x, and then the first limit that I am asking for is right over here. So this is limit as x approaches to a. Do you see a little minus in the corner? The minus in limit, that stands for left, and then the plus means right. Left hand side for minus, right hand side for plus. So the first limit right there is limit as x approaches to a from the left hand side. What is the function equals to, or I should say what is the y value equal to? So left hand side is right over here. Just follow my cursor. So as x approaches to a from the left, y approaches to c, right? So the first answer is that is equals to c. And then we do have a solid point when x is equal to a, y is equals to c, because there is a solid point over there. What about plus? A plus means x approaches to a from the right. So x approaches to a from the right. Do you see my cursor? Right hand side. As x approaches to a from the right hand side, y approaches to b. So this is equals to b. But is that means when x is equals to a, y is equals to b? The answer is no. Why? Because a comma b is an open circle. So when you are thinking about function evaluation, when x is equals to a, y is not equal to b. Y is equals to c. Because a comma b is an open circle. Open circle means there is nothing right over there. But when you are talking about limit as x approaches to a from the right, y approaches to b. So when you are thinking about the word approach, the limit exists. But if you go straight to a function evaluation, nope, a comma b is not a solid point. How about d? So as x approaches to d from the left, right here, y approaches to b, right? So that is equals to b. Do we have a solid point? Yep. When x is equals to d, y is equals to b. And then how about d plus? D plus means as x approaches to d from the right, so here is your right hand side, x approaches to d from the right, so looks like there is an arrow and that goes all the way up, so that means that is equals to infinity. And then sometimes when you do when you try to evaluate a limit, you get an infinity. That means the limit does not exist. For does not exist, we don't write the whole thing out. Does not exist, we write DNE. That stands for does not exist. Do you still need to write the infinity? I always write it out. So infinity does not exist. All right, moving on to the next graph. So the next graph, I have the function f of x equals to 1 over x, and then here is the graph. That shouldn't be something, you have to look into your calculator. So the graph of 1 over x is right over there. There are two asymptotes, one horizontal, one vertical. So the vertical asymptote is at the y-axis, which is x equals to 0, and then the horizontal asymptote is on the x-axis, that is y equals to 0. So now, let me ask you a couple limit questions. As x approaches to 0 from the left, so x equals to 0 is where? Is the vertical asymptote, right? As x approaches to 0. Follow my cursor. As x approaches to 0 from the left, right here, right over here, x approaches to 0 from the left. Do you see that the curve goes all the way down? So that means negative infinity, right? Negative infinity. What about x approaches to 0 from the right? So that goes all the way up. So you have a positive infinity. And then can you write DNE? Yep, you can write DNE and then DNE. And then how about as x approaches to 0 from the left hand side and from the right hand side? So in this one, we have the left limit equals to negative infinity, the right limit equals to positive infinity. They are not the same, so this one I will just say DNE. Okay, so how about the next two? X approaches to positive infinity and x approaches to negative infinity. So positive infinity means you look all the way to the right hand side, right? So as x approaches to positive infinity, so since we have a horizontal asymptote, the curve is getting closer and closer to the horizontal asymptote, but will never touch the horizontal asymptote. So if you look all the way to the right, we are going to say that as x goes all the way to the right, y is approaching to 0. So this one I will just say equal to 0. Y approaches to 0. Equals to 0, I'm not saying that y equals to 0 exactly. Again, the keyword is approach. Y approaches to 0. I am using the word approach. All right. How about negative infinity? Look all the way to the left. Look all the way to the left of the graph. You have y approaches to 0. Okay, last one. So this one, I have a function f of x, and then I have two horizontal asymptotes, one at x equals to a, one at x equals to b. So for x goes to positive infinity, so how do we look at the graph? X goes all the way to the right, y approaches to a. So y approaches to a, and then x goes all the way to the left, y approaches to b. So that's the quickest way to introduce limit. And then once again, when you are thinking about limit, just forget about the function evaluation. You plug in an x to get a y. You have to think about when x is getting closer and closer to a value, y approaches to what? So as x approaches to a number, y approaches to what number? So use the keyword approach. When you are thinking about limit, when you are looking at a picture, think about the word approach. All right, so that is the end of this video. If you think my instruction is helpful and clear, give me a like, share the video for me, subscribe to my channel on your way out. I will catch you all in the next one. Signing off for now.